2 times by half or divide by 2. So write this out. For a triangle, it's going to be area equals base times height over 2. Base times height over 2. Now, there's 3 slight little different variations of this for an acute, an obtuse, and a right triangle. So in an acute triangle that you guys are mostly familiar with, we have area equals, and our base, like that. Our height is inside at a right angle over 2. So that's just your regular old run-of-the-mill acute triangle. Base times height over 2. Height is inside. In fact, put a little note next to the H. You'll understand why in a moment. Write the word in. Okay, I got a little animation here for you. Okay, take a look. The reason why I'm careful to emphasize is inside. Here's your base, here's your height, it's inside. But watch what happens when we make an obtuse triangle. Watch. Okay, that's a right triangle, there's obtuse. Where does the height go now?
Outside.
Okay, warning, every single SAT test, if they give you an area of a triangle, they will never give you the nice simplistic acute. They will always give you obtuse, without fail. I've never seen one where it gave it on the inside. Okay, so it's going to be on the outside just to try to trip you up. So it is the same thing, absolutely. The only thing you have to remember, so it's area equals base, which is only from the edge of the circle, times the height, but the only thing you have to remember is height is now outside the circle. I mean, not the circle, excuse me, the triangle. Okay, so here the height is outside. So you just follow the eyeball there. And in all SAT tests, they tend to use that one, just to make you, just so they didn't, you know, height makes a right angle. Versus this is where the SAT test, they'll always give you an answer that uses that side. And you're never going to make that mistake, because you remember height always creates what kind of angle? Right. Height creates what kind of angle? Right. Good. Oh, now, a right triangle, the equation's a little bit different. Technically, it is base times height over 2, but I have a slight variation, and I'll tell you why there's a variation in just a moment. So for now, right, base times height over 2, and there's going to be a variation here that I prefer. So what I show you over here is going to be the preferred version. Okay, look up here. Let me show you why. Whoops, I keep going to the wrong one. Okay, so there is acute, it's in. There's obtuse, it's out. When you see a right triangle, say the word stop. Stop. Okay, right there. Okay, that height, where is it? It's on a what? No. What do we call this? In right triangle language, we call it the leg, or one of the legs. So what I want you guys to realize is, give me the one, that one right there, is our base and our height in a right triangle are the legs. The base and the height are the legs. So this is the preferred version. I'd rather you guys use this in a right triangle, leg times leg, over 2.
So either way.
Either way, but just be really, really careful. Let me show you why I actually prefer leg times leg over 2. Take a look here. I'm going to draw another right triangle. You don't have to draw it, just watch. See that? Oh, that's bad. Oh well. Yeah, that is okay, let's try this again. Sorry. Let's be a little bit more accurate. Okay, watch carefully. There's my right angle. Great. Where's base?
Both the legs.
It's not here. See, that's the problem with the right triangle. If I rotate it and you guys have base and bottom stuck in your head, you're going to get this wrong. Here, the base and the height technically are right here, leg and leg. It honestly doesn't matter which one's which. So when we get to solids in which we're going to be rotating that right triangle quite frequently, it's just leg times leg over 2. You just remember that. That way, no matter which way I rotate it, you're not going to be tripped up. All right? Let's put you to work here. We're going to do 3 problems together. Actually, no, only 2. Yeah, 2. 2 from the moment. All righty. So we start by writing our equation. In equations, we write area equals has 2 sides with an equal sign. If I ask you for the equation of a triangle, like to get out early today, possibly, and I ask you for the equation of triangle, and you say base times height over 2, you do not get out of my classroom.
Area equals.
Area equals.
Because an equation has an equal sign.
Two sides with an equal side. There will, but not today. The song will come up later. So now watch, we go area equals, let's trace our base. Out loud, what's our base? 7. Yeah, it's 7. We don't count that 3 there. That's there to kind of like mess with your head. Problem is, do we have the height?
No.
Put an X there. Yeah. You're just ahead of the game. Okay. But look what we got going on here. What kind of triangle is that? Good. Let's start working that X. You should have recognized it, that it's Pythagorean theorem. Guys, big hint, if you have a right triangle, there is a very good chance you're either using Pythagorean theorem or SOHCAHTOA, one or the other. So for X, I'm going to freeze that, do that without a calculator. Yes, sir. What's up, buddy? Well, we want, see the word, we want to find the area. It says find the area there, Jalen. But the problem is we wrote the equation down. We realized we're missing something, so now we're having 100 or something. Yes, sir. Yes, it is. You even remembered your triplets. I am so impressed. Yes. Guys, what's your height? It's a triplet.
The height is 4.
It's a triplet.
When do we even
Yeah,
learn
actually, I remember there were 6 triplets I told you to memorize. 3, 4, 5. 6, 8, 10. 5, 12, 13, 9, 12, 15, 7, 24, 25. These are all triplets that work in the Pythagorean theorem. If you memorize them, you don't even have to do the math. You just know, oh, it's a 3, 4, 5 triangle. Okay, so our height is now 4,
14?
right? And now the key to multiplying is not actually multiplying. We just divide. Yeah, we could. And, of course, it's just 14 units squared. I don't provide units for you. Okay? All right. So I want you to take a shot at this one all by your lonesome. No, you may not use a calculator. No, you may not use a calculator. Yep. Go ahead and do it. Get your hands off the calculator, guys. If you're done right now and bored, page 8 is your kill time page. I'll wait another 30 seconds, but never be bored in this class. Go to page 8 if you're not done, or if you are done. Alrighty. Ask a neighbor what they got. Go. Yep. Alrighty, guys. You got it right? Yeah. You got it right? Nice job. Alright. Okay, Dennis. Alrighty, guys. So a triangle is just base times height over 2 area equals. Now, we're going to go into the other shape, because remember there was 2 shapes we're going to work with today. Triangles, and then what's called regular polygons. I want you to look at this and just quickly take 10 seconds and define in your own mind what is a regular polygon. Write it down. You've got 10 seconds. I'll pester you in just a moment. It's just the very next page. So to the right, that's a regular polygon. That is a regular polygon. Bless you, dear. Thank you. So, Michael, what do you think a regular polygon is?
Polygon. Yeah. And equal sides.
You're right. Equal sides and equal what? Angles as well, because sides imply these angles are equal as well all the way around. Okay, so what in the next about 4 minutes, the equation you get, it doesn't matter how many sides you have. If it's a regular hexagon, pentagon, hexagon, decagon, dodecagon, 123 gon, this equation works for it all. The only key is it has to be regular, which is congruent, sides, and angles. So for a trapezoid, it's impossible for this to work because a trapezoid can't be regular by definition. But before we can go with this, there's a little bit of vocabulary I need to talk to you guys about. A little bit of vocabulary. 2 simple words. Radius and apothegm. Radius and apothegm. Okay, so here's a circle. I'd like you to trace the inscribed hexagon. So start tracing the green. Just physically trace it. It's inscribed because the corners are right on the edge of the circle. That's called an inscribed regular polygon. Now in this circle, the radius goes from the center to the edge of the circle. And because of that polygon, the radius is forced to go also to the corner. So we're going to transfer that over here. A radius in a regular polygon goes from center to the corner. From center to corner. Always. That's a radius. In a regular polygon. Yes, from a center to the corner. And it cuts that corner in half. Not quite, because it's no longer technically a circle. I only stuck it in a circle so you can see the word radius. You're used to seeing radius in a circle. Well, it's also in a polygon, if it's theoretically inscribed. Okay, we could do a square as well. Now, an apothegm, also known as apothegm, kind of depending on what dictionary, a radius goes from center to corner. The apothegm goes from the center to the side, specifically the midpoint, so it cuts a side in half. That's called the apothegm. It also automatically creates a right angle. So it goes from center to side. The apothegm goes from center to side. Radius, apothegm, A-P-O-T-H-E-M.
So this story. Hi.
Hi, Tori.
All right, guys. Ready? Every person must do this. Take 10 seconds each to explain what is the difference between a radius and an apothegm. Go. 10 seconds each.
Go.
Radius goes
When you
to
go from a center to corner,
Every person must talk, even if you're just repeating yourself. Alrighty, guys, look up here. At some point today, look up. You are going to be finding the perimeter of stuff. Word to the wise, when you do perimeters, you do not use your eyeballs. You do not simply look at it. You put your pencil on the paper, and you physically trace. So start tracing the perimeter. You physically trace wherever you see the word perimeter. Whenever I demand you to find the perimeter, you will physically trace it. Always. You absolutely will.
We should make a song for that.
Yeah, we're getting there.
Trace the perimeter.
Always trace the perimeter. Yes, something like that works for me. So you count it. That's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So perimeter here equals 64 units. It's not square because it's just length. That's 8 times 8. That's 8 times 8. If you had traced it, we would understand that because it's trace it. There you go. Now, I want you to do the one on the right. You may not, repeat, not use the calculator.
Trace the perimeter.
I recommend that you do, yes. You do have to trace it, yes. No calculator. Yes, ma'am? Sorry, there, Nikki.
You're not putting it underneath it.
You can sit back there. You can sit back. Sit back. Got it? Okay. What'd you get?
You 91.8.
What do you do? Just double-digit multiplication, guys. What'd you get? Okay, guys, look up here. Where is the 10.2, dude? That is the question. Alrighty, so my little admonition here is always trace your perimeter. With that skill, we're ready to get the equation. Okay, ready? Not yet. We'll get there. So, not today, next class. Area of a triangle is, of course, base times height over 2. Do you see there's a triangle here? I'd like you to trace that triangle and just pull it out here.
Well, which triangle? There's a whole bunch.
There is a whole bunch. Just trace the one, sir. Just trace the one. That's your base. There's your height. Yes, sir. You know, you are welcome. I may toss some extra credit. I don't rap. No, not Chapel. My class, maybe. If you write me a rap. Ready, guys? We're almost there. Remember, there's 2 equations today. I'm going to lose you guys. Wait. Look up here. Ready? So, we know the equations, base times height over 2. I'm losing you guys. This takes 2 minutes. And then here, extra credit. Does that interest anybody?
Yes.
Then pay attention. Okay. Now, taking a look here, the base of the one triangle is here. Let's trace it. And our height is right there. Now, when I said trace the triangle, Dylan's first reaction is like, which one, Miss Way? There's a bunch of them. That's my point. A regular polygon, go ahead and put your hatch marks in there. A regular polygon is made up of a bunch of triangles.
I have a question.
Yes, sir.
So, since, see how there's like dotted lines in the
Uh-huh, yeah.
and it's like the radius?
Yes, sir.
And since that would be like the base, so then is 10 the radius?
No, the 10 is the base.
I know, but look.
10 would not be the radius there, buddy.
Look, in the,
Wait a minute, yes, actually it's a hexagon, yes, it would be in this case. But that's not always going to be true. Okay, watch guys. Here, if we want to get all the triangles all the way around, we're going to take the bases, trace them with me. Ready? Trace that base. Do it with me. Trace. Trace this base.
trace that base.
Trace. Trace. Okay. All the bases together is actually the what of the shape?
Perimeter.
Aha. Okay, so when we do our equation, we're going to replace base with the word perimeter. See, it's not that you have to memorize the equations by brute force. They're all related. Yes, it is. Now, height here, over here, we don't call that height.
It's the base. It's
No.
called the base.
No, what's it called? That's not the radius. That's the apothem. This would be the radius. Apothem. So the word height is going to be replaced with apothem. So our final equation looks like this, guys. For a triangle, it's base times height over 2.
Base times height.
That's for a triangle. And for a regular polygon, it's going to be perimeter
Times perimeter divided
Perimeter times apothem over 2. Or my preferred version, area equals paw divided in half.
What?
Area equals paw divided in half.
So you're
Pa.
saying my paw is going to be half what it is now?
If that helps you remember, you take paw divided in half. Yes. Ready? We're going to do 2 problems together. 2 problems. Yeah, there's 2 kind of sections. Do you guys need a break? I think you need a break. All right. Ready? I would like you guys to sign. Step number 1, write the equation. Area equals perimeter times apothem over 2.
So you have to find the perimeter.
Yes. Okay, ready? Area equals, let me show you where I'll let you use the calculator. Physically trace the perimeter. And you guys figured out if you counted that, that's going to be 8 times 8. That's your perimeter. Circle apothem, physically trace and circle the apothem. Again, don't pick stuff with your eyeballs.
You just plugged in 64 right away.
Yes, you could at this point. All right.
No, 9.7.
Oh, you're right, it's 9. I stand corrected.
You can't trust your eyes.
That's true.
That's why you got it.
I gotta trace it and all that good stuff. Ready? At this point, once you have the equation and the plugins, you may grab a calculator. Go. Did you trace the perimeter?
Yes.
Did you trace the perimeter, Carl?
I'll always trace.
Good. How many sides do you have?
Hey, Dub, super soon.
I'm actually pretty hyped right now.
You're welcome to stand and...
I'm going backward, Dub.
Okay, this should literally take you just a few seconds to finish this, guys. All right, guys, you there? Ready? There we go. 310.4. All right. I'm going to shorten this just a bit. You're going to skip 3. You can skip 3, but I want you working on problem 2. 2 is the last one we're going to do together, and then you guys are going to be on your own. Don't do 3. Skip 3. Start, if that'll make you happy. Excellent. Then I want you doing 2 now. Excellent. Glad to hear it. All righty, guys. Start working 2. Problem 2, a regular hexagon has an area of.
Hex is 6.
That's correct.
I should have learned that in my 3rd grade. In a single side.
Once you have your plugins, yes.
So we're trying to find the alphabet.
Yes, you're trying to work backwards. Yes. Well, ask yourself, what could you at least write the equation down?
I did write the equation.
Then circle, plug, chug.
Why do you have the equation, Evan?
Yes, what do you have?
We have the side length and the area.
You're right. So circle, plug, chug.
680.4 equals. What do you think?
This side length,
97.2.
Yes, yes, you may.
Hey, don't smart talk.
Duke, what was your question, buddy? Your kill time page is page 8. Page 8's your kill time page. Okay, did you guys get it?
Oh, yeah.
But we're not doing the teamwork activity? Do we do the teamwork activity? Wait, do we do the teamwork activity?
Yeah, we're getting there. Okay, students, there's your answer. Now, let me explain to you how to earn extra credit. Start to finish, this will take you about 10 to 15 minutes. Page 6, you're going to work together as a team. You read it out loud. You do it as a team. Then page 6. Page 6 is kind of like your warm-up. Hang on, let me stop my...
Oh, hard this is?